Hello everyone and welcome to our channel. Today, we'll dive into the future of space exploration, a fascinating topic that spans both the most ambitious missions and the emerging technologies transforming our approach to the universe. Get ready for an incredible journey as we explore the next frontiers of humanity in space. Let's start with NASA's Artemis program, an extraordinary initiative aimed at returning humans to the moon by the mid-2020s. This program is not just a race to set foot on the lunar surface again. It represents a long-term strategy to establish a sustainable human presence. The Artemis III mission will bring the first woman and the next man to the moon, exploring the lunar South Pole, an area of enormous scientific interest, not just for geology, but also for the presence of valuable resources like frozen water. These resources could be used to support future missions and even produce fuel, paving the way for further explorations, such as missions to Mars. NASA is already studying the use of water extraction and electrolysis plants to convert frozen water into oxygen and hydrogen, providing astronauts with life support and fuel for rockets. Additionally, Artemis plans to build a space station called Gateway in lunar orbit, which will serve as a staging point for missions to the moon and, in the future, to Mars. This station represents a crucial step for human exploration of the solar system, as it will provide a place for research, astronaut training, and mission resupply. Thanks to its strategic position, the Gateway will also serve as a platform for astronomical observation and the study of space radiation, contributing to mission protection and our understanding of the space environment. NASA is not alone in this adventure. Other space agencies, such as ESA, the European Space Agency, and CNSA, the China National Space Administration, are joining forces to build lunar infrastructure and develop advanced technologies. Imagine lunar bases equipped with laboratories, habitats, and life support facilities where astronauts can live and work for extended periods. These lunar outposts will not only serve as stepping stones for Mars exploration, but they could also offer new opportunities for scientific research and technology, including experiments on living in extreme conditions. The International Lunar Program, which also involves commercial and private partners, could lead to a thriving lunar economy, with activities such as resource mining and energy production. For example, extracting helium-3, a rare isotope on Earth but abundant on the moon, could provide a clean energy source for the future. Speaking of Mars, the Red Planet is undoubtedly one of the primary targets for the future of space exploration. NASA and SpaceX have big plans for its exploration. SpaceX is developing the Starship rocket, designed to carry humans to Mars and beyond, with the vision of establishing a human colony on the planet. But before sending people to Mars, we need to ensure we have the right information. Currently, the Perseverance and Curiosity rovers are working tirelessly to analyze the Martian surface and gather data on its geological history and the possibility of life. The Mars Sample Return mission, planned for the next decade, will be a crucial step. It will collect samples of Martian soil and bring them back to Earth for in-depth studies, opening new frontiers in our understanding of the planet. Furthermore, the Perseverance rover is also testing technologies to produce oxygen from the CO2 in Mars' atmosphere, an essential technology for future human missions. This innovation, known as MOXIE, Mars Oxygen In Situ Resource Utilization Experiment, represents a fundamental step towards self-sufficiency in Martian missions. The plan is to develop methods to create fuel and oxygen, reducing the need to bring everything from Earth. But exploration isn't limited to the Moon and Mars. The icy moons of Jupiter and Saturn, such as Europa and Enceladus, are becoming increasingly intriguing to scientists. These worlds could host subsurface oceans that provide conditions favorable for life. The Europa Clipper mission, planned for 2024, will explore Europa in detail, analyzing its surface and searching for signs of life. This will be a fundamental step in understanding not only the potential for life on Europa, but also the geological and chemical dynamics of this extreme environment. Similarly, NASA's Dragonfly mission, launching in 2027, will send a drone to Saturn's moon, Titan. This drone will study the chemistry of its dense atmosphere and methane lakes, offering a unique glimpse into a world that could hold the keys to understanding life in extraterrestrial environments. Titan is particularly intriguing for its chemical composition, which is unlike any other celestial body in the solar system. Researchers are eager to discover how prebiotic chemistry might work in such a different environment and how this could inform our search for extraterrestrial life. Titan's methane lakes, for example, could host methane-based life forms, a concept that challenges our conventions about what constitutes life. Now, let's talk about the technologies that are making all this possible. Reusable rockets, like those developed by SpaceX, have revolutionized the space industry, making launches more affordable and sustainable. This not only democratizes access to space, but also spurs innovation in the sector. Other companies are following suit with projects aimed at making space travel more accessible for the public and small businesses. Commercial space companies are also developing new launch systems and spacecraft, increasing competition and leading to rapid and significant advances in technology and cost reduction. Moreover, advanced propulsion technologies, such as ion and plasma propulsion, offer new possibilities for deep exploration of our solar system. These propulsion systems will allow faster and more efficient travel, bringing probes to destinations that once seemed unreachable. For example, electric propulsion, which uses electric fields to accelerate ions, could drastically reduce travel time to Mars and beyond. Innovations in robotics and artificial intelligence are equally crucial. These technologies can help manage complex missions and collect real-time data, optimizing operations and ensuring missions achieve their scientific objectives. Autonomous rovers, for example, can navigate and make decisions without human intervention, allowing them to explore remote and dangerous regions without risking astronauts' lives. This kind of autonomy is essential for long-range missions where direct support from Earth is limited. Another area of innovation is space telescopes, such as the James Webb Space Telescope, which is already providing extraordinary images of the universe. These instruments allow us to observe distant galaxies and study the atmospheres of exoplanets, enhancing our understanding of the universe and its evolution. The Webb, for example, can observe in the near-infrared, revealing details about objects that were not visible with previous telescopes. Future telescopes, like the Roman Space Telescope, promise to further revolutionize our view of the universe, allowing us to study cosmic phenomena even farther away in time and space and increasing our ability to discover Earth-like exoplanets. Another key aspect of space exploration is international cooperation. Projects like the International Space Station, ISS, have demonstrated how nations can work together to achieve common goals, sharing resources and knowledge. Collaborations between space agencies, universities, and private industries are creating a dynamic ecosystem that fosters research and innovation. This global approach is essential to tackle the enormous challenges that lie ahead in space exploration and to ensure that missions are sustainable and successful. In conclusion, the future of space exploration is bright and full of extraordinary possibilities. With planned missions to the Moon, Mars, and beyond, combined with emerging technologies and growing international commitment, we find ourselves at a crucial moment in humanity's history. We are only beginning to scratch the surface of the universe's wonders, and the discoveries that await us are beyond our imagination. Stay tuned for further updates as we continue to explore the latest news and discoveries in this fascinating field. Thank you for joining us on this journey into the future of space exploration. If you enjoyed the video, don't forget to like, subscribe to the channel, and activate notifications to stay updated on all our content. See you in the next video.